Greetings and welcome. Ladies and gentlemen, have you ever wanted to solve all of the world's issues with people being treated unequal? That's not what you're going to figure out how to do here today, I'm sorry. We're solving inequalities, though. This is what we've got. And what I think I want to do is talk about what some of these inequalities look like. Let's do some recall, first of all. Some straight-up number line inequality stuff. What if I wanted to graph x is less than 2? All right, x is less than 2. So I would draw a nice little number line. Number line is a one-dimensional graph, if you think about it. And for my number line graphs, I'm not looking for anything fancy. I usually want 0 labeled on it, and I want the point of interest labeled on it. And hopefully spatially those are arranged properly. For instance, I wouldn't have put a positive 2 over here. That would have been like a negative 2 or something like that. But you don't even have to label that much. And if you wanted, you could throw some other tick marks in, but whatever. But positive 2 is the point of interest for us. What does this say? I said it just a moment ago. X is less than 2. So I'm referring to all points that are less, not including, but less than 2. So for instance, is 0 one of those points? Yeah, so 0 is hanging out in there. Is 1 one of those points? Yeah. Is 1.5 one of those points? Is 1.5 and a half one of those points? That's not actually how they say things. 1 3/4? How about like 1.9? 1.999? 1.999999999. What about 1.9 repeating infinitely?
Yeah.
Technically, no. We'll talk about that later. I'm really tempted to now.
Why? No.
We'll clarify that in a moment. But my point is, would negative 2 work?
Yeah.
Yeah, that's less. Right, so what I would draw is I put an open circle here and I shade to the left. Right, so all of the points that work, there are infinitely many of them, and my kind of little shaded area here represents all of my solutions. Now the open circle at 2 means it's everything up to 2, but not including 2. Right? So that's the idea there. What if I have x is greater than or equal to negative 3? Let's draw that. Kablam, kablam. So I've got 0, here's a negative 3. And now this one, because this is greater than or equal, it's got this or equal portion to it. It will be a closed circle, or filled in, because it includes negative 3. And this would be shaded to the right. Right? So not bad. So everything to the right all the way to infinity, which technically you can't get there, are solutions to that inequality. All right, let's have this little side discussion here. I'm going to write this in pink, I think. Let's see. Sidetrack. Let's see. Which of these is true? Is 0.9 repeating equal to 1? Is 0.9 repeating less than 1? Or is 0.9 repeating greater than 1? And this will be my A, B, or C options. Let's see. How many people would vote for A?
Wait, can we say that question one more time? Can you say it?
0.9 repeating, right?
Yeah.
Is it? Well, actually, let's see. How many would vote for C? Let's start with C.
Even though you said it was wrong.
I've got 1.
Makes sense.
How many vote for B? 1, 2, 3, 4, 5 vote for B. And then how many would vote for A?
Yeah.
I might have suggested that a moment ago, right? Maybe you guys didn't believe me. That's fine. For those of you who voted B, if those are different numbers, okay, which is what you're saying, right? If it's less than it, then it's not the same. So, That's fine. I understand that. That was a matter of reading the symbol, but that's fine. If these are different numbers, then this is my question. 0.9 repeating plus what would equal 1? Like, what could go in this box?
1.
1? That would be 1.9 repeating. 0.1. Now, actually, this is a little bit tricky to explain here. 0.1, if I do 0.99999 plus 0.1, is that what you're saying? Right? This is going forever, though. What is 0.1 plus 0.9? 1. Yeah. I'd have too much. So what else could it be?
It couldn't be anything.
It's equal to 1.
Then someone might say 0.01, and then they'd end up with 1.009 repeating. And then someone might say like 0.0001, and then they'd have 1.00009 repeating, right? So the issue is the thing that you'd want to put there. Let's see if I can. No. There we go. Technically, what you'd need to put here is infinitely many zeros and then a 1. But that can't happen. Because the moment I'm like, all right, I've got this infinity train moving, and I'm like, all right, stop the train, I'm going to put a 1 right here. The infinity train is no longer an infinity train because it stopped. Right? And I'm like, oh, okay, no. Well, let's get that 1 back on the train, and let's keep the train moving for a while, and then I'm going to stop it and put the 1 that, nope, can't. So this number does not exist. All right, so that's an explanation of that.
But how is it equal? Is it equal to 1 then?
Well, let's see. Let me see if I can explain this algebraically, maybe. Let's suppose let x equal 0.9 repeating. All right, I've just defined that as a variable. Okay. What if I multiply both sides by 10? We know how to do algebra, right? 10 here, 10 here, right? So I will have what? 10x equals, what's 10 times that do? 9.9 repeating. I shifted the decimal, so there's technically infinity minus 1 nines here, but that's still infinity, okay, just so you know. Like subtracting 1 from infinity doesn't actually do anything. Okay, so do you guys kind of agree with that? Right, 10 times that, I just shift a decimal, bam, good. The next thing I'm going to do is I'm going to subtract x from both sides. Well, I'm going to subtract x here, and here I'm going to subtract what x was equal to. What was x equal to in my assumption? 0.9 repeating, right? Those are the same thing, and I can subtract the same thing from both sides of the equation and not change its equality. Would you agree? So what is 10x minus x? 9x. And what is 9.9 repeating minus the 0.9 repeating? 9. You see where this is going? And I get x equals 1. Exactly. But at the start, I started with the assumption that x was equal to 0.9 repeating. So either these are the same, or I made a mistake.
Whoa.
All right, here's another way to think about it. What if I have, what is 1/3 equal to? 0.3 repeating, right? What is 2/3 equal to? Technically 6, infinitely many 6s. So what would 3/3 equal? Well, let's see. 3/3 would be these two added together, right? So 2/3 plus 1/3 is 3/3. 0.3 repeating plus 0.6 repeating is 0.9 repeating. But what is 3 divided by 3?
That's not possible.
It is.
Understand.
And what I'm saying here is this is exactly equal to 1. I'm not rounding up. It's exact.
I'm so confused.
This is good stuff.
Freaking me out big time.
So 0.9 repeating, it just happens to be another way of writing the number 1. Just like how 3/3 is another way of writing the number 1. So that's weird.
So the answer was A.
So the answer was A, yeah.
So, if there was ever an answer on a test, one, and write that answer. One.
I would say it's not the simplest way to write it.
Right.
Well, if the answer was 1 on a test and you wrote 4/4, I would probably take off a point for not having it simplified.
Well, what if you wrote 0.9 repeating?
Is that simplest form? I don't know.
Yeah.
But anyways, I just want to point out that those are equal. And that's 3 explanations as to why it is. So, anyways, that's all sort of good stuff. One other thing I wanted to do for recall before we got any further. Recall continued now that we had an awesome little side discussion here. I really like that discussion, by the way. What if I have, let's see. How does 2 relate to 5? If I was to have to put some sort of symbol here. Less than, right? Okay. What happens if I multiply both sides of this by a negative? Let's say I multiply by -1. Okay? Now I would have -2 and -5, right? But the problem is exactly what you're saying. -2 is not less than -5. -2 is greater than -5, right? Think about a number line here. Man, these sound effects are amazing. How do I do these special effects? Wow. 5 and 2, and this one is.
Why did you put 2 behind 0?
You got me. You got me. Good catch. Good catch. -2 and -5. So at first I had 2 is less than 5, right? Which is true because it's to the left. Think about less. Left. Right? Maybe a little bit. Meh. And look at that. It's even this symbol is kind of like just a crooked L. Is it? Maybe. Is it?
I'd say so.
Yeah. So that's how one way you could remember it, maybe. And now when I multiply both of those by -1, I had -2. And it was going to say -2 is less than -5, but it's not true because -2 is not to the left of -5. And in fact, if I had to be in debt, the amount of debt I'd want to be is $2 rather than $5. I think you'd agree. Unless I knew I was going to declare bankruptcy the next day, then I'd probably want to accrue as much debt as I could. But that would be unethical, friends. Please. So I just want to point out that what would you say we should do when we multiply by a negative, as a general idea, if I'm dealing with inequalities? What happened? Yeah. So when multiplying, and in fact, or dividing by a negative, flip the inequality. Okay? So that's really the number one fact we need to know for this lesson. Whenever you multiply or divide by a negative, flip the inequality. So let's do an example. Solve. What if I've got 2x plus 1 is less than, let's say, I don't know, 10. You already wrote 10, didn't you? That's fine. I could change this to 6, to 2x plus 6, just to make it a nicer number. Doesn't matter really, but whatever. How would you solve this if pretend this was an equal sign this whole time? What would you do? Okay, I like it. I like it. And, oh, do I have to flip the inequality when I subtract a number? No. No. That just shifts things along, so that's fine. So 2x is less than 4, and now what do? Divide by 2. Do I have to flip an inequality whenever I divide?
Yes.
No.
No, yep, only when it's dividing by a negative. So the solutions are every number that's less than 2. Every one of them. As a matter of fact, one of the ways you can do a check, well actually let's G-Rafe this real quick. So we have a visual representation of our solution set. That's, I know you guys know how to graph this. Is this open circle, closed circle?
Open.
Open circle. Which way am I shading, left or right? Left, because those are less, right? So there we go. So those are our solutions. Now if I want to do a check, which I'm not going to make you do checks tonight, but or at least formal checks, I could technically plug in any number in this shaded region. What's a super easy number to do math with? 1. What's even better?
0.
0 is a really nice number to do math with. So let's check this with 0. 0 is like the man when it comes to doing math. 2 times 0 is 0. Plus 6 is less than 10. Is 6 less than 10? I believe it is, friends. I believe it is. Cha-ching. Not bad. Not bad. Let's keep moving right along. I think maybe a couple more examples is all I'll need. What if I've got, will it just be a couple more now that I think about it? Do I have to do compound today? I don't. Good. Whew. I was worried there for a minute. What if I've got -2 parentheses 3x minus 4 is greater than or equal to, I don't know. Yeah, 12 sounds good-ish. Sounds perfect, actually. So, what do you want to do? Yep, we could do that. We could do that. I'm going to distribute, but you would definitely not be wrong for dividing by -2 in this case, especially since it wouldn't complicate
That
anything.
first line almost looks like absolute values.
Oh, yeah, almost, yeah. That'll be tomorrow. Nope, Monday. Oh, let's see, then what would I do?
Add 8 or subtract 8.
Yep, subtract 8. Make sure your inequality symbols don't suddenly change into equal signs as you're doing your work. Sometimes that happens. Let's see, 12 minus 8, their signs are different, so I subtract them. Who's more influential? 12 is positive. And now what do? Add 6? No, we don't add 6. We divide, friends, because that 6 is being multiplied. And wait, did we just say divide? Divide? And I'm dividing by a negative? That means I'm going to have to flip it. Get the spatula. Bam, flip it. And there's my answer. Answers. There's technically infinitely many of them. If I was to graph this, man, that's an amazing line. I'll pretend. 0. Let's have. Watch this. Watch how cool this is. Here's -1, and I want thirds, so I'm going to go bam, bam. How about that? Let's see. Is this going to be an open circle, closed circle? Closed because, bless you, because it's got the equal to portion. Where's -2/3?
There.
Right there. So, blam. Which way am I shading?
Right. Towards 0.
Towards 0? Towards 0?
No.
Why?
No, yeah.
This is a less than symbol, so less is to the left. Right? Yep, so we'll just have to memorize and remember the little L for less. And anything that isn't an L is a greater than. Yeah, so it takes a little bit of memorization there. So yeah, anytime you multiply or divide by a negative, flip the sign. Actually, let's even put like a big note here for ourselves later. Flip. Bam. And let's do one last example. Zoop. Zoop. How am I doing on... Oh, this video is not too long. I'm fine with this video length. This is okay. Let's do one more example. Let's have... what if I've got 5x... No, negative 5x, how about? Plus 7 is greater than, I don't know, negative 2x minus 9. Peculiar. Yes. Yes. What would you want to do if you were solving this? You can just really pretend that this is an equal sign, and then you just have to remember our one rule.
Negative sign.
You'd move 7?
I'd go 9.
Oh, 9.
You'd move 9?
5.
Let's move some x's first.
Oh, I get it. Negative. You have to move negative 5.
Negative 2.
Why?
Why are we moving the negative 5x?
Because you always have the big one and the big one.
Because negative 5 is littler than negative 2. So that's what I would recommend, but that'll avoid negative numbers later. So let's see, I'd have 7 is greater than. Oh man, I hate writing 7s next to greater than signs. Am I right? Math problems. Hashtag. Let's see, now I know where I'm moving my stuff, so I'm going to move this 9. This is good. Ooh, 16 is greater than 3x. And divide. And I've got 16 thirds is greater than x. That's weird to say it that way. Because it might get confusing, shading and whatnot. Which way would you guys want to shade on that if I was to graph that? I go to 16 thirds, which is about 5 1/3, 5.3 repeating. Where would I shade on that? Left or right? Are my points bigger or smaller than it?
Bigger and little.
The values of x, are they bigger or smaller than this number? They're smaller. If this is bigger than x, right? So x is smaller, so I'd want to go to the left. Now watch, here's a way to fix that. Let's just do this. What sort of sign would I write here? Less than, right? If I'm flipping this around, I'd actually have to flip the sign with it. And then I can just kind of do the, less than the whole time, and that's a lot easier. So that's not that bad. So that's the idea. It's really the same as solving an equation, other than when you multiply or divide by a negative, you flip the sign. And actually, if you really wanted to be, I don't know, maybe I find this amusing. What if I was solving this equation? How would you solve that equation? Divide by negative 2. And watch this. Ready? Watch. Watch. Don't forget, you got to flip the equal sign. Am I right? I know you guys like that one right there. You always have to flip it. I know if you didn't, I'm going to take off points if you don't. So, all right, so there's solving inequalities. So it didn't solve any of the unfair treatment and prejudices of people in the world, but maybe it brought us all closer together because we know how to flip an inequality sign when we need to, you know? Maybe. Math is, after all, an international language. Actually, I just heard today that every culture laughs. Isn't that great? It's beautiful if you think about it. Bye-bye.